Every OEM quality lead I talk to after a public recall asks a version of the same question. Could this happen to us? After a decade sitting across the table from device companies, the honest answer is almost always yes, unless you can point to the specific gate that would have caught it. The Abiomed Impella cluster is a useful teaching case. Between 2024 and 2025, J&J MedTech worked through a string of Class I recalls across the heart pump platform. The failure vectors are specific, and they map cleanly to gates a mature build program is supposed to hold. Look at what actually failed. A pump driver circuit assembly with a possible capacitor issue. Impella CP sets that shipped out of specification. Purge retainer cracks traced to the force applied during disc insertion and removal. These are not exotic failure modes. They are the kind of thing an in-process gate is designed to intercept. Under the QMSR, the FDA framework incorporates ISO 13485-2016 by reference. That matters here because each Impella vector maps to a clause an auditor can name: component qualification, process validation, final acceptance, and environment control. 4 gates, 4 clauses. LSO is built around these same gates. FDA registered, ISO 13485 certified, 12 clean rooms across 3 facilities and 125,000 square feet of controlled space. The proof bar exists because these controls have to be in the line by design, not bolted on after a recall. Take the purge retainer cracking. A force-dependent assembly step is exactly what Clause 7.5.6 calls a process where output cannot be fully verified afterward. If the force window is not validated and monitored, a crack that forms during assembly can pass a visual check and still fail at the bedside. The out-of-spec CP set is a different question. Clause 8.2.6 requires documented acceptance activities across receiving, in-process, and finished device stages, with authorization before release. The uncomfortable question every OEM should ask is how non-conforming product cleared final inspection and reached distribution. One more note on the labeling correction. Updating the instructions for use addresses how the device is used. It does not touch how the device was built. When a Class I risk is resolved with a labeling change, the upstream design transfer and assembly controls stay exactly where they were. Here's the checklist I would hand an OEM team this week. Requalify safety-critical suppliers, validate every force-dependent step, trace a recent lot end-to-end through acceptance, confirm cleanroom class matches device risk, and check the device history record shows inspection was actually performed. A recall cluster like this one is a warning label for the whole industry. The vectors are specific, they map to named clauses, and they are catchable. The OEMs who come through a review like this in good shape are the ones who can point to the gate, show the record, and prove authorization happened before release. Talk to our team.